afternoon, everyone. My name is Bidong Liu. I'm with Data and Analytics Solutions. Today, I will present create interactive motion charts using R package Google VIS. So data visualization is very popular in data science field now, and compared with traditional charts, motion chart has its own advantages. It is a great way to show multiple variable changes, especially over time. And one person we must need to mention is Dr. Hans Rosling. Because of him, a motion chart becomes more and more popular. He puts lots of motion charts in his TED Talks, and then this format be liked by more and more people. And the question is, if we only know the program language R, or if we just finish data analytics and data manipulation within R, could we create a similar fancy motion chart using R? Yes. Now we have the R package Google VIS. Google VIS was developed by Max Gassman and Diego de Castro. It is an interface between R and the Google Charts API. And Google Charts has the motion chart, so we don't need to upload our data to Google. We just need to only use R to generate the similar motion chart without the help from any other softwares. So here we have a demo using the data medical expenditure panel survey data to show how the motion chart looks like. Okay. This is a motion chart for the topic expenditures by medical conditions from 1996 to 2014. This is for United States national level. And each bubble represents one medical condition. Here are 62 bubbles. Let's play so we can have a general idea of the motion chart. The y-axis stands for total expenditures, and the x-axis stands for population. This motion chart has the following features. First, other than the y-axis and the x-axis, it also has the color and the size. So each color stands for can have meanings also, and similar as size. And also it has the year trend. So it relieves much more information than traditional chart. And second, for each dimension, for example, the y-axis, we have multiple variables to choose. Here now is total expenditure. We can switch, for example, to hospital expense. So it will change it to another total new expenditure. Or we can choose the color to prescription medicine cost. And the third feature is that the bubble of interest can be highlighted. Since here are 62 bubbles, data users may not be interested in all of them. So we can select the ones that we are interested in. For example, we can select cancer, or we can also select mental disorder. So the other medical conditions will become transparent, and these two we are interested in can be clearly observed. And when it moves to the end year, we may have already forgotten the status of its starting point. Here we have the option to have charts. So it will show the check of how the movement in the years. And even for the speed, if we think it's moved too slow, we can easily adjust the speed to make it move fast, or make it to move even slower. So this is a highly interactive motion chart. And because it has so many options for each dimension, even though here it's one chart, actually it can have a similar effect of dozens or even thousands traditional charts. So next, let's see how to generate this chart. First, we need to prepare data. So the data set, we can either generate it in R or in other format, which can be imported or read by R. And then let's see the data set we have for this case. We have the the time variable. Here is year, and we also have the ID variable, which is for bubbles. Here is condition, and we have other variables for the other dimensions. And step 2, we need to generate the motion chart. Of course, we need to load the package. If it's the first time, you may also need to install this package. And then we need to set the initial state for this motion chart. This motion chart, besides the bubble chart, it can also have the type of bar chart or line chart. So if you want to set the initial state for bubble, then needed to set the icon type as bubble. We also set the variables for y-axis, x-axis, also color, size, and time. 1996 is the starting year for the play date. And play duration here we set as 24,000, which means 24 seconds. So if you want to this motion chart play in 10 seconds, then simply just set it as 10,000. The parameter non-selected alpha, point 2 here is the transparency for the non-selected bubbles. So if you want to those unselected bubbles totally go away, then we can set it as 0. The function to generate motion chart is GVIS motion chart, and my data is the input data set. And we have ID variable, time variable, and also we can set chart width equals 800. Here is 800 pixels, and we can simply display the motion chart using the function, and it will show in this way. This web page will be hosted by our internal HTTP server, so it's in a temporary folder. It's not good for share with your clients or your readers, your friends. So the third step, you may want to publish the motion chart. The motion chart can be output using print function, so into the text file you want, and then simply you can copy paste the content in the condition in the file, and to your whatever your blog, your target website, and it will show. So others, when we communicate with our clients or other users, they may ask whether can be the motion chart displayed on a smartphone or iPad. Yes, but this motion chart is based on Flash. The default browser is a smartphone, not support Flash player, but we can simply download one from Apple Store or from Google Play. And this motion chart for the they have certain requirements. So it needed to be the same since this this package is an interface with the Google Chart API. So this needs to be same as Google. You can check more details from this website. And I listed two. So yeah, it's easy. So just the numbers for the month, day, year needed to go in 4 digits year and then month, then date. Okay. For others, so the motion chart, the color can be variables or can be same color or unique colors for each bubble. So the code is unique color or unique color. For the size, it can be unique size 2, same size 2. So the code for the same size is unique size. And for other variables, the ID variable, it can be either numeric or a character variable. For same as for color, but for other variables, they have to be numeric. Can be, if they are character variable, then the error message will show up. I think I'm almost done. So here, reference. They have a menu, official menu from Chrome, and also Google Motion Chart. And if you are also interested in the maps data, you can check this website. Okay. Thank you. I'm sorry? Browser? Okay.
Well, we'll be posting the slides, so I think the link would be on the slides, right?
Yes.
Yeah. It wasn't on the slides, that's why. Oh.
Oh, this web page. This is Google Blog. So for demonstration, we simply put it on Google Blog. Yeah, but if you want to put the
Can you send us the link to that?
yeah, sure.
Send it to Mike.
Yes, it's on the on my slide.
Okay, that's what I thought.
Does Google API require payment? Do you have to set up a relationship with Google?
Google, do you have to pay for that?
No, I don't pay it.
No. No payment.
Thank you.
Is this yours?
Can you mail the link for the organizers and then donate?
Yeah, that'd be great. Thank you.
So next we have the top slide.
Okay, who's the next speaker? Which one are you?
Can you share the WebEx with R?
Yeah. But which one are you?
Oh, well, I'm using R.
No, but I mean, which one are you?
Oh, well, that, but I'm using, like, those slides over here.
Oh, so you don't want those at all. Okay. So if you have to go outside of this, if you bring up something else, you might just have to do share.
Okay.
If it's not shared.
All right, good afternoon, everyone. My name is McLeod Brown. I work here at Bureau of Statistics in the Office of Compensation and Working Conditions upstairs, and mainly I work on the Occupational Requirements Survey. But today we'll be talking about automating occupational profiles on market. So just to give everyone a little bit of background about the ORS and what it is, so besides the career statistics, staffing compensation survey programs, so everyone's familiar with the point conflict, the responsible compensation, the same office. But the ORS provides job-related information regarding physical demands, environmental conditions, education, training, and experience, and cognitive and mental requirements for jobs in the U.S. economy. An annual survey, and we want to produce data at the national scale, so not the state or metro level. Also, the ORS is one of the newest surveys at BLS, having just released its first set of estimates in November of 2016. So, ORS profiles. Along with the news release and the data that is released with the ORS every year, we also release occupational profiles. And essentially, these are high-level overviews of different occupations throughout the United States economy using ORS data. Currently, we have 40 ORS profiles available on our website, and they all feature a pretty standardized layout. We'll have an image, a chart featuring unique estimates, and then a paragraph summarizing each different requirement. So physical, environmental, education, and cognitive and mental. So, like I said before, they're very standardized, so they make for a great reason to automate it. Here is an example of what they currently look like on our website. As I touched on before, there's an image of whatever occupation you're looking at, a chart with the various estimates that you're looking at, and paragraphs summarizing each requirement. So, the current process and the reasons to automate it, it's very repetitive as it is right now. The way that we put these together currently is very brute force of us. Staff will just spend hours combing through the different estimate databases, selecting which ones they find interesting, and then writing it up, putting it into a profile for public dissemination. This also drains resources from other programs in our office, and it especially conflicts with ECI and ECEZ processing. Also, with our latest release of the ORS data, we now have estimates for 420 occupations. And as I touched on before, we only have 40 occupational profiles available on our website. So 420 minus 40 is 380 occupations just waiting to be written about. So why R Markdown? Well, we first used Python, but it didn't turn out as neat as we wanted. As everyone in this room is familiar, there was a lot of cleaning the data beforehand, and it essentially just turned into one big, messy, if conditional for loop. Example would be like if requirement column includes environmental, and estimate column is greater than 90%, pull it. But if the environmental or if the requirement column includes physical and it's less than 9%, don't pull it. So just stuff like that. The output was not as neat or compact as we would like. So we asked ourselves, how can we make something prettier? To R Markdown we turned. R Markdown is great for similar documents that staff is recreating over and over and over again. It's cross language, meaning you're able to incorporate your language of choice into the document. So if you were comfortable with Python or even SQL, you can implement it into R Markdown and you can build on your program off that. There's also built-in support for static and dynamic outputs with HTML, cascading style sheets, and JavaScript. And there's awesome documentation and tutorials online. Here's a little bit of R Markdown starter code. So this at the top will be your code for pretty much any R Markdown program that you put together. You'll have the title, the author, the date. That is the code, so if we actually ran that code, it would be today's date, month, and year. But this header is known as the YAML header, which stands for yet another markup language. And this is where you're going to, once again, put all the stuff that makes your output kind of certified. There's the title, author, CSS. If you deal with figures and you only want them to be a certain height or width, you can put it here. Also, you can incorporate shining. And then at the bottom, I listed the run document or the knit function. You can essentially treat that as a print function, but with R Markdown. So, our current R Markdown product. It is functional, and it does create a profile for each occupation in our data set. This chunk of code is kind of the hub of what we're working with, and is what allows us to incorporate the different occupations that we currently produce estimates for and output them into profiles. So what this is saying is we're bringing in each estimate, we're grouping it by stock code, and then we are splitting the estimates from the stock code and the occupation title, where we have the drop-down menu. The Michael Jordan variable, that's not really what it's called, but just a variable, that is how we kind of get the drop-down feature. We make it reactive. Once again, it inputs the stock code for us, and then it allows us to choose whatever occupation we so desire. Essentially, you're performing a VLOOKUP. So, this is what our product currently looks like. So, as you can tell, it's once again very standardized. You will have the occupation requirement survey at the top, followed by what the orders is. There, we have the drop-down menu that we just discussed, and then it kind of gets into separating each profile individually. So you'll have the description of what the profile is, what they do, and then it lists out different physical demands, environmental conditions, education, training, experience requirements. And this year, we will also have cognitive and mental requirements. So if you were to scroll down on this page, you would get to a chart of the occupation you're looking at. Here, we have minimum education requirements, and we only have 2 bars here because we only published 2 minimum education estimates for waiters and waitresses. But if you were to go back and choose, say, the all-worker level in that drop-down menu, you would see about 6 or 7 different bars because we would publish more estimates for that occupation. But once again, it's very reactive. And here is an example of the drop-down menu. The user can either click this drop-down menu and then scroll through to find whatever occupation they're looking for, or they can go ahead and type it in and it'll automatically populate. So some cons of the current R Markdown product. It is dynamic, but not as dynamic as we would like. It shows the same types of estimates for every occupation, and that's not great because not all estimates are created equal, aka are missing or just not interesting. So as I touched on before, we do publish estimates for 420 occupations, however, we will not publish the same amount of estimates for each occupation. A good way to think about it is, do we care about the percent of firefighters that are exposed to extreme heat? Probably. I mean, we expect it to be high, but it's still an interesting estimate. Do we care about the percent of librarians that are exposed to extreme heat? Probably not. So, as the tool stands now, we're stuck with both. So how do we fix that? So we've identified 3 main ways to improve our tool, and I've ordered them by long-term goal to short-term fix. We have machine learning, the params function, which is specific to our Markdown, and then we have grouping by major occupation group. These are all viable options, but how feasible is each? This guy. This is Carl Brogan. He's a professor in statistics at Wisconsin-Madison. Part of the presentation, so just keep that in the back of your mind for a minute. Okay. Improvements continued. So the short-term options are, once again, the params function or grouping at the 2-digit stock code, major stock code. So the params function offers great flexibility within our program. Parameters are declared using the params field within a YAML header, and it's great for kind of drilling down your data. Think about specific geolocation profiles or specific time periods. That's something that we're currently exploring right now. Also, for the short term, and what we're considering doing for this iteration of the orders is grouping at the major stock level. So we are hopeful that the major stock occupations should be similar enough that they make decent profiles. So all the management occupations will be together, all the production occupations will be together, all the farming, forestry, and wildlife, all those things. The long-term goal is machine learning. So we can kind of do that 2 ways, either supervise or staff can go through and choose the interesting estimates, and then we kind of build a model off that, or unsupervised where we would rely on the program to kind of identify clusters of estimates that are similar, and then we can kind of go back and tune it. This is a program for being such a young survey, and that if we start to do this now, we can hopefully easily build this towards a productive future for us. Also, the reticulate package, so if you're a rookie like me and you spend half your time trying to replicate Python code in R, the reticulate package essentially just takes whatever Python code you already built and brings it into R for you seamlessly. So some pros of the current R Markdown product. If we roll this out tomorrow, it would already save our staff hours of data review and profile creation. We are confident that it reduces time from scanning data and pulling estimates. It creates charts for staff according to what estimates they want to see, and the main responsibilities of staff would be fact-checking and copying and pasting. The Orders is also a very diverse data set with many different types of estimates, so we want to use this product in other programs, it should be fairly easy to implement. One example is the model wage estimates. That is another program within the Office of Compensation and Working Conditions, and that produces wages at the national, state, and metro area level. So we like to think that if we can get this program nailed down for a diverse data set like the WARS, then bring it into another program that only deals with wages, for example, it could be seamlessly to instrument. Also, a big initiative going on in our office right now is standardized fact sheets, where this will be a reason to incorporate this in the future and other similar reproducible documents. Another slide. So that's about all I have on our current program and what we are working with, but just to give you a, I guess, further bonus about our Markdown and how beneficial it is, was that this entire presentation was also created in our Markdown, specifically the Sharingan package. And this is just the example of the YAML header that you would use if you want to do your own presentation in our Markdown. For people that remember our buddy Carl, that is that YOLO true command. That's the thing. If you put YOLO true in your YAML, Carl will randomly appear in your slides. However, there is the option to make it so it's not Carl, and if you want to see your cat, in your presentation, you can just put it into your cat. Anyways, there's also an option to incorporate cascading style sheets. So there's a bunch of cascading style sheet templates already built into Sharingan. However, you can also use custom CSS as well. So I personally implemented the BLS template for PowerPoint into this presentation, so you can incorporate your custom CSS style. For anyone that's familiar with JavaScript, a lot of this is built off the Remark JavaScript package. But the main idea to take away from this is that our Markdown is flexible, useful, strong solution to incorporate into repetitive processes. It is great for streamlining repetitive processes. It's great for building presentations, and it's great for putting pictures of random people you don't know into your presentations. Information, questions, comments, tips, and/or advice are always appreciated.
We're going to continue to do our automation.
I have a question. Do you have a go-to site for our Markdown? I know that every time I would sort of come up with the same link, like some tidy Markdown type thing.
Yeah, it's actually linked in these slides, but the R Markdown, I'm pretty sure it's the first link when you Google. It's actually built in R Markdown. It's called Bookdown. And there's just a scrolling feature there where you can learn R Markdown just by scrolling. But if you just Google R Markdown, I think it's rstudio.rmarkdown, I think. I don't have the slide in front of me, but
maybe I'll email you separately. Your email isn't up anymore. It's brown.mcleod@bls.gov.
yes, that's correct. Sounds good.
Thank you.
Thank you.
So to continue on our Markdown journey, apparently it's a good day for our Markdown. I'm going to talk about, I'm Alexandra Gates. I'm a principal data analyst at NORC at the University of Chicago. I'm going to talk about how we used our Markdown to automate the development of customer reports in Word, which was a fun little adventure. We're going to go through this set of topics. We're going to do a little background about why we're doing this and what we're doing, the pre-processing we did, visualizations, my favorite part, which is the customization and figuring out the customizations that we did, and then working with Word and some lessons learned that we learned in the process. So a background, what are we doing? We have primary data collection. We're collecting from approximately 500 healthcare facilities across the United States, and we're doing this for about 4 different data sources. So we wanted to tell each facility how they're doing on these series of data sources against a benchmark by facility size and then also across different months. So that's what we're doing. Why are we customizing reports? Not all facilities gave us all data, so we want to make sure if a facility didn't give us one of the benchmarks or one of the pieces of data that we wanted, we don't want to give them an empty table. And we could, because we don't want to go back and forth with 500 facilities and explain to them why there's an empty table in their data set. So it's not totally altruistic, partially selfish. And then the last thing is why are we, part of the purpose of this is to create easy to understand graphics. we want to do this so that facilities are actually using this to inform what they're doing, and to, if they're below a benchmark, we want them to improve. If they're above a benchmark, they get a gold star. And then again, we want it to be as easy to understand because we don't want to talk to 500 facilities about what's in their reports. So a little busy, but the overall process that we're doing is we have a master facility file. We use that to create data issue flags, and that's how we're able to customize our reports. We have 3 different data tools, turns into different benchmarks and a ranking that we create, and all those go into different exhibits. Going back to the right side of the screen again, that the master facility file and the data issue flags that we create all help us with the report customization, which then go into separate Word documents for each facility. So for pre-processing, we do pre-processing partly because our analysis is only as good as the data that we're using. We are extremely lucky that we have analysts that are turning all these primary data sets into data that's fairly usable on our end. It's already a wide data set, but we want to turn it into a long data set because ggplot likes long data better than it does wide data. We also use the data that they're giving us to create labels in the data and the graphs, and so it's a lot of pre-processing to turn it from something that a machine reads to what humans read. To do this, we use the tidyverse mainly, dplyr, and that should say tidyr, and then specifically gather and spread for going between wide and long. For visualization, ggplot, again, tidyverse, and then its cousin or sibling libraries. We mainly use graphs, line graphs and bar graphs because they're the easiest we've found for facilities to understand what data we're giving them. And one interesting thing, one fun thing that we discovered is that we could create a variable that would change the type of text that are in the graphics, so each of the labels. We change it between bold and plain, so it's easier to see which is the facilities number versus which is the benchmark number. We were able to create an actual variable and pass that into ggRepel to make that differentiation between the two. Another thing we had to choose, we wanted to keep a continuous theme across different graphics for the facilities, and then also we wanted to be careful with what colors we chose, because a lot of the facilities don't have color printers, and we want, when they actually print it out, we wanted it to be as different as possible, as distinct as possible, to see what's going on for them when they're in a board meeting, hopefully, discussing how well they're doing. So for production, we start with a master facility file, and then we have about 8 different scripts that are doing this, and the last 2 are working together. One's a master script, and then one's a knit report. In the master file, we make a loop that goes through the facilities and actually applies the data in the master facility file. So in the master facility file, each row is a facility, and each of the columns are different flags. And so for each iteration, it goes through the facility and then labels variables as the different flags. And those variables are what are called in our markdown file to make the customizations. And I'll show a little bit more about that. It makes the loop a little bit very long because it's many different variables for each month that's going on, but that's how we were able to do it. And so this is the customizations, and this is my favorite part. So we did 3 different customizations. One was at the paragraph level, one was printing variables, and then one was printing tables. So we're getting data for each month. Some months facilities didn't give us their data. We want to tell them why. Also, there might be an outlier in a month, and we want them to know why their data isn't being included in the benchmark. So we were able to figure out, so in our markdown, there's chunks for paragraph text, and there's also chunks for code. And so in the chunks for the paragraph text, we were able to figure out that we could do an if statement, so if.dot.issue, and then it would, if there was a data issue, then that whole paragraph would show up. If there wasn't an issue, it doesn't show us false, because it's a if-else. So yes, no, true, false. And so the same thing for each of these variables. And each of these are January through June right now, because we had through Q2 data. So we were able to do, for any month that there's an issue, it shows up. If there's no issue in that month, it just doesn't show up. And so we've turned these different reasons into each of the months. And the same thing for the tables. So in each of our chunks, there's different options at the top. It's red. I can just screen. I think the battery went. So for the table, there's multiple different options in each of the chunks of the chunk. We were able to figure out that we could actually do a data-driven chunk evaluation is equal to a variable, and that variable is data-driven. So if we just don't have data for that table, it doesn't show up. We actually have another paragraph that shows up saying, we don't have data for you. And that was the way that we were able to get around having these empty tables and having to talk to all these facilities. So we also have a YAML. Ours is, and we have a reference document, a separate reference document for Word, and in that reference document you can put headers, you can put page numbers, you can put font sizes and bolding, italics, and then I recently discovered you could also do margins accidentally, and that was kind of fun. It sounds really simple, but didn't know that. And then the paragraph spacing. Things that were more difficult is table formatting. Especially in Word, in HTML, knitter is fantastic. In Word, it just doesn't do that. So that was where we had our difficulties. So our lessons learned, there's a difference between missing and non-existent data. If it's an NA, ggplot skips it. If it just doesn't exist because we have time data, so if we don't have March data, there's a line through that without a little dot. When we were rendering into Word, special characters and extra spaces in the names of the facilities, because it was all data-driven, we wanted to use the facility names, it just stopped our production, which is great when it takes you 7 hours and you have to go back and redo it. QC is important. We all know that at this point. And then R plus Word is extremely flexible, but it does take a little bit. It's not as easy as HTML or PDF is with our Markdown. And the last thing, we now have about 25 images or graphs in our files, and so each of the file sizes are starting to get a little unruly, and we have to start figuring out how to remove them. So my partner in coding has been Mina Zhang. She has moved to Canada since, so she wasn't able to be here, but I just wanted to give her a shout out and say thank you to her. And then team at NORC, they've been great. And then my email, if you want to get in contact with me. Happy to hear what you guys are doing for customization, and I'm happy to share what we've learned. And then also, thank you for your time.
Do you need to use other R packages to make use of Word, or does R Markdown, where the output is Word document, is that all you need?
Let's answer the question, and then can you repeat your question later, please?
Yes.
What was the requirement that versus an R Markdown output? Yeah, so each facility wants to be able to change it a little bit, or so if they wanted to go to a board meeting, they wanted to add something or add context or whatever. So I wanted to do PDF, but we stuck with Word for their use the program.
Can you ask the question again?
Nothing good is ever lost, for whatever you put out into the universe is what you will get back. Mona can.
I don't think that's a valid question. Anyway, we can repeat the question later when we're done with all the talk, time permitting. Okay? Thanks, Ajahn. This is great. All right. Next we're going to have our next call about EEOC and investigation.
Okay, can everyone hear me? Okay, great. All right. My name is Ada Harris, and I work with the U.S. Equal Employment Opportunity Commission. And the title of the presentation is Linking EEOC Case Investigation Records by Employer Name Using Text Analytics. Okay, there's just a quick overview of what I'll be discussing during the presentation. Okay. All right, so the EEOC enforces federal laws that make it illegal to discriminate against a job applicant or employee because of the person's race, color, religion, sex, including pregnancy, gender identity, and sexual orientation. Also, it makes it illegal to retaliate against someone if they participated in a discrimination case, filed the case, or even just simply a query. All right, if an employee believes that discrimination, if they've been discriminated against, they can file a charge of discrimination with the EEOC, and it gives the EEOC the ability to investigate it and take remedial action if discrimination is found. Okay. So why is this important to the EEOC? So I'm going to be talking about using administrative data, and it's important to the EEOC because we're a small agency with limited resources trying to make the most impact on our data, understand emerging trends, understand causes and industries or geographic trends of discrimination. Okay, and just to mention, each year we get about 150,000 inquiries to questioning if something that someone experienced is discrimination, and from that, about 80,000 to 90,000 charges of discrimination are filed annually. Okay, so we'll discuss IMS, Integrated Mission System. It's an internal information management system and data repository for case investigations, also known in-house as where all the charge data is kept. So there's multiple components to IMS. There's the private sector tables, federal hearings, litigation tables, outreach, and as well as federal appeals cases. For this particular talk, I'll be focusing on private sector companies. And within the private sector table in IMS, it tracks everything from intake to investigation, settlement, and then closure. And there's really about 5 main tables in the private sector employer a component of IMS, and it captures the charge table, captures the charge number that's assigned for each charge. There's an allegation table that explains the basis for the allegation. For the remainder of the presentation, the respondent name I'll be referring to as the employer, discrimination. There's the action table that tracks the movement of the case, and then finally we also keep information on the person that submitted the claim of discrimination, like gender, race, things like that. Okay, so the problem is that when IMS was stood up, there's really not a way to link respondent names, that is employers, in the data set. All we have is a respondent name. And over time, name changes to businesses, variations, different data entry. And mind you, EEOC has 53 field offices across the U.S., so anyone can go to any of these 3 field offices and file a complaint of discrimination, and it can be entered differently. Okay, no problem. So the purpose of this analysis is to identify unique respondent names and determine whether they should link to other respondents. Okay, here's a challenge example. In this example, private company represents a exact lexical similarity, but to the human, it's very easy to understand that these private companies are different, even though they may share the same exact word in their title name. And a couple of other things that we've also seen in the first example there at the top, we've got hyphen versus spaces, just variations of input, and then also sometimes you have a respondent that will identify a specific store, but it may be linked to a particular trade name, and there's also variations of the business name and then doing business as a trade name, something like that. So just variations in input. Okay, so the approach I took was to develop a search query for respondent names to model the degree of similarity between the respondent name and all respondents within IMS. So the question here that we're trying to answer is how close are 2 pieces of text in lexical similarity, meaning the same character, and semantic similarity, meaning the same meaning. All right. All right, so We had about 10 years of IMS data, and we had approximately 1.4 million observations. I conducted some pretty standard text cleanings, removed punctuation, converted all of the text to lowercase, trimmed the white space, and removed stop words. From that, I went to a deterministic deduplication, and you can see that the size of the data increased significantly just after cleaning for unique duplications. Okay, so from that, we turned the employer names into n-grams. In this case, they were characters, and it's just a little example of the variation of the n-gram versus the bigram versus the trigram. Okay, and then from there, we took our terms and we turned them into the TF-IDF. And basically, it's a measure of how important a word is to the document, and really gives an opportunity to do math on our terms. So, for example, consider a document containing 100 words where the respondent's name appears 5 times. For the TF, where the respondent's name will be 5 divided by 100, or 0.05. Assume we have 10 million documents and the respondent name appears in 1,000 of them. Then the IDF is the log of 10 million divided by 1,000, which is 4, and then we take the product of those two. Okay, finally, move on to the cosine similarity. It is used to calculate the similarity between the two IDF values. It is a measure of orientation and not magnitude, and which is why it performs particularly well in our case, where we don't want to give a large weight to a word that may appear very frequently. It is also known as a normalized dot product. So in this example, I'm showing an example of the output where the actual company's name is masked, but here we're just showing some similarity scores, and I'm describing the different variations of its performance. And overall, it's performed well. Managed to capture when names could be input in different orders, if there's an and in between the names for some reason, and things of that nature. Okay, so working again with EEOC respondent, so using a manual string search, EEOC, and this was by manual visual groupings, classified approximately 7,780 of the approximately 600,000 observations using manual string search. But implementing the entity linkage approach, we were able to capture approximately 16,000 of those 600,000 observations. And we saw about the same similar results for respondent 2. So overall, we felt that this was performing better than just doing a simple string search. Okay, so there's always so much to be done, but overall we learned that multiple entries corresponding to the same entity is often a problem occurring in databases and can lead to a loss of information. Growing data constantly creates challenging problems and opportunities for linking data, and overall the record linkage helps to find information about respondents and extract actionable data from the IMS database to support leveraging internal data to understand respondent charge frequency. And in our next steps, decreasing time to results, introducing parallel processing, and then also we're always looking for a golden standard data set with correct business names to help learn more from. And then also my next step of focus is on analyzing cutoff scores for classifications, because manually going through each one of the observations is certainly not practical. So identifying the best cutoff score to classify. And then finally, from there, hopefully taking those cutoff scores and then adding in some automation and machine learning to learn more. Okay, thank you.
All right, our last topic for questions will be on testifying Python, and the speaker will be from BLM.
So which one's you?
I am the third one.
Third one, David?
Yep.
Okay, are you going off? Is yours just the PowerPoint? Okay, good. Makes it easier. Perfect. Thank you.
Okay. Hello, everyone. I'm David O from the Office of Compensation and Working Conditions at the Bureau of Labor Statistics. So in this presentation today, I'll be going over some of the challenges and constraints in implementing a randomized control test design and how Python was used to overcome these difficulties. So let's get started. So first, as a background, in early 2019, our office developed a machine learning prototype using the occupational requirement survey, which McLeod went over earlier during this session, and some other supplemental data sets. So this prototype predicts the top 5 most likely standard occupational classification codes, which we refer to as SOC codes. And in May, a team was formed to investigate how this prototype that we developed would work in practice. So, in other words, the team was tasked with testing the feasibility of implementing the machine learning algorithm into the actual production environment, specifically in the microdata review process. So, late July to early August, during the final 3 weeks of OR's collection cycle, the team was allowed to conduct the pilot test in the actual production environment. So there were 2 main questions that we wanted to answer out of this pilot test. The first is, what are the effects of computer-assisted review on SOC codes? Specifically, we wanted to know its effects on the participants' time spent reviewing, its effects on the number of questions being sent out to the data coders, and its effects on the review resulting in a positive change. The second question that we also wanted to answer was, do exposures to machine learning algorithms output result in reviewers favoring or maybe not favoring specific SOC codes? So there are studies that have documented user bias created from recommendation systems. So we wanted to make sure that if these biases do exist in our system, that we will know how much is affecting it. Okay, so now to measure these causal effects, right, we need a randomized control trial. And our experimental design had 8 participating reviewers reviewing multiple incoming data. Each time a participant reviews a quote, he or she will be randomly assigned to either a control group or one of the 4 treatment groups. So this diagram here shows how the random assignment would work. So when assigned to a control group, the participant would not receive any output from the machine learning algorithm. But when assigned to one of the treatment groups, the participant will receive some variation of machine learning algorithm output. Okay. So now this type of experiment, while it's ideal in practice, right, are often not done because due to various challenges and constraints faced that the team must face, right? So here I'll go over some of the challenges that we had to overcome. And first is that for us, some information were readily available in our currently existing production and review system, such as what the SOC code was, and indications of whether a question had been sent out to the data coders or not. But the other information that we wanted, like the time participants spent on reviewing the SOC codes, as well as what the reviewer thought the correct SOC code was, were not being captured in the existing system. So those are something that we had to overcome. Second challenge was the random assignment. So our test design requires that for every incoming data that our participant reviews to be randomly assigned. And in a production setting, this will be very difficult to do. So going along with that, we had to make sure that the pilot test does not add too much burden on our reviewers. The experiment would have to be as natural as possible and not disturb the existing production that's going on at the same time. So, and lastly, the time constraints. So this presentation is titled The Rapid Implementation of Test Design Using Python. And the term rapid here refers to the fact that we only had a little over a month to developed and implement test instruments. This was after coming up with the test design and getting it approved by the management. So faced with these challenges and constraints, I think the battery ran out. Faced with these challenges and constraints, it definitely didn't make sense for us to work with our systems office to have the machine learning algorithms incorporated into the existing system. Instead, we opted to develop our own standalone application using Python. So the benefits of using Python to develop the test instrument was that it was the same language used to develop our machine learning algorithm. Therefore, it was straightforward for us to import the model into the application. Also, given multiple participants, some in the regional offices, with varying degrees of computer literacy, Python is able to create a standalone executable application that can easily be shared and distributed to staff that are not here with fairly simple instructions. And other benefits of Python included being able to take user input, accessing database, outputting various prompts depending on the random assignment, and to write to a centralized data set once the participant finished his or her review. So here is what our test instrument actually looks like. So once the application is opened, the participants are first asked to input their database credentials. Okay. Once that has been verified, then they are asked to input the identification information for the data that they are reviewing. The application then retrieves the relevant information from the database and performs the random assignment. And the prompts would vary depending on what the random assignment was. So for example, here is the prompt for the treatment group number 1. Here the instrument indicates whether the currently entered stock code matches or does not match one of the top 5 predicted stock codes by the machine learning algorithm. It also provides the top 5, what it thinks is the top 5 most likely stock codes to be, and then also provides the probabilities that are corresponding to these stock codes. So that was our treatment group number 1. On the other hand, if the participant was assigned to treatment group number 2, he or she would not receive the probabilities associated to the stock codes. Okay, and then the last example is the control group, and here we see that no prompts are given regarding the results from the machine learning algorithm. So once participants are exposed to or not exposed to the treatment, they are asked to answer some follow-up questions in the application. So given the information, whether they found the entered stock code to be correct or not, and if they thought it was incorrect, then what they believe the right one was. And then we also asked about how familiar they are with the currently entered stock codes. Also in the background, we would track their time to understand whether the treatment affects the time that they were spending reviewing these stock codes. Okay, so now that the pilot test has completed, here are some items that could be improved for the next iteration. So first is to create a robust centralized data set or database structure for collecting information. So during the pilot test, there were some instances of our application crashing on the users due to just heavy usage, multiple people trying to write to the same data set at the same time. Also, based on the feedbacks from our participants, we think maybe a web-based application might be better for the users for their user experience. So those were some comments that we received. So in conclusion, our pilot test successfully ended in early August with almost 1,500 incoming data reviewed using the test instrument. And despite the challenges and constraints we faced initially, the flexibility of Python language and its various applicability to, enable the randomized controlled crossover trial to be rapidly implemented. And so now you guys might be wondering, so what is the results from this test? And well, it is currently being analyzed, and we hope to share the findings with you all sometime in the future. So, yeah, thank you.
We have plenty of time for questions, but microphone is there. Probably it's a good idea for the speakers to step forward and ask whatever they have to ask. So, right on time. So I don't know if now it's more practical or not. Maybe it's better for the speakers to step forward, and I'll hand the microphone to whoever has questions. Questions? Your audience? Maybe I'll do some icebreaking to start with. So here for your test design, there's a lot of software like the Z3 and the like. So what's Python find you inconvenient that you don't see out of software using experimental?
The reason why we leaned on Python was because I was comfortable with Python, and that we kicked off, as I mentioned in the presentation, we kicked off this team in May, and we were supposed to have everything ready by late July for the actual pilot testing. So we had about two and a half months to really figure out what do we want to measure, how do we want to design this, and then how are we going to measure this variables. And to be honest, I'm not familiar with these other experimental software that we could use. So I thought, hey, I know Python language, and I know you can create applications that can easily be sent out to other people without them actually having Python installed on their laptop. And then also it has all these functions that are built in that you can, take user input, access database, and read in the models that we already created. So it just made everything convenient for us in that sense.
All right, more questions?
I have a question for Vidal with the interactive motion charts at the beginning. I remember hearing about the Gapminder project with the original idea of those four-dimensional graphs. It's very useful. They have a lot of information going on at once, which is useful, but sometimes it's not as easily interpretable. What clients or what situations do you think is best to have high information density versus straight interpretability?
I think motion chart is very useful, especially in the face of investigation issues. So, for instance, we have we want to check the medical conditions, each medical condition, the cost or the population. But initially, actually, we don't know which one has the most cost or most population, and we don't know which one we should pay the most attention to. So with motion chart, we can have all those medical condition information based on it, and then we can investigate which one moves more quickly or has more cost. Then we can pick some of them as most ones needed to investigate. And so this is the most useful period, and it's not only for this period. Then if we want to show the data as I demonstrated, we can pick two of them or three of them to show their movement. So in the second phase, I think it's also
very good for visually noticing outliers.
Yes. And sometimes if there's only a table, it's not easy to find those everything. But with the motion chart or with the animation, easy for us to make it work.
Right, more questions? So that's quite a bit of time. A question about the whole Python process. Thing is, curious what like the libraries you're using or whatever to generate Python.
To be honest, with Python, as far as I got was I was using pandas to really clean the data, and then about 3 months ago, we had an in-house seminar here about introduction to R Markdown, and we also had a gentleman by the name of Thomas Mock that he presented from R, trying to give us an overview about R Markdown even further. So that really immediately turned me on to R Markdown, so I kind of abandoned the Python process pretty early on, I guess you could say.
Hello, I have a question for Dana. I work with agencies in the real world and many enforcement agencies have the same habit they have. They've had problems of not just entering the data incorrectly for addresses for employers, but have you noticed any issues with when you're trying to match the respondents and the employer names? Have you noticed anything with addresses, and in particular any sort of just in general, and then any sort of content, there's this kind of fly by night, addresses. Have you noticed anything you're trying to match address data to, or what's the address data involved?
So currently we haven't looked into address data very much. We've really of late been focusing on kind of like what we would consider the top employers across the U.S. and they are not always do they identify, because it is manually entered, not always do they identify the address of the corporation. Sometimes they enter the address of their a business or wherever they work. And so a lot of times I think addresses make it difficult because most of the employees that we've been looking at are across the U.S.
Are there multiple fields for business name and legal name, kind of in corporate structure?
So currently there's not, but that is one of the things hopefully that we can offer to the intake process when they're speaking with the charging party to really drive down to is it a specific entity or is it the corporation?
Okay, for a question? All right, well, probably it's better to go ahead and let you guys ask what the speakers and stuff. Probably there you have your unique question, but you don't want to stuck at the microphone. So I think that's better you go back. Great talk to everyone. This is actually particularly on R Markdown and using all that machinery to make it work. So we're all learning great from you. Thanks.
Honestly, it's very early.